Okay, today we're going to do some multi-step events. So suppose we take a coin which has two outcomes when flipped, heads or tails. We take a die which has the 6 outcomes we saw last time, 1 to 6. And we did both things. We flipped a coin and we rolled a die. And we were thinking about how many outcomes there would be in total. All right. You can't just add them together, right? Because something else is going to happen. Now, the way we visualize all of the possibilities, there's two ways of doing this. We can use a table where one dimension holds the outcomes for one of those experiments. Say the coin, heads and tails, can go there. And the other dimension would hold the possibilities for the other experiment, like the die, that can go there. Right? And we fill the table by matching up those entries. And this gives you all possible outcomes from doing both things. So for example, the little T3 would mean I flipped a tails and rolled a 3. The H5 would mean I flipped a heads and rolled a 5. The other way, maybe more commonly used, the other way of visualizing this stuff is using a tree diagram. Okay. Now how this works is we pretend we're doing those two things one after the other. So we're going to start by flipping the coin. If you do that, then there's two options. You either have heads or tails. So they go there. Then we're going to roll the die. But this is the maybe more tricky part, because when we roll the die, we've got to think, well, if I got a heads, right, then when I roll the die, I could have 6 outcomes, the numbers 1 to 6. But maybe when I flip the coin, maybe I got tails. If I got that, I could also have the 6 outcomes of the die, numbers 1 to 6, they also go there. Right, and so that's how the tree diagram looks. And I guess the confusing thing when we first see this is that it looks like the die has appeared twice, right? It looks like the die has been rolled twice, but it hasn't. Okay, this is still only one roll. The reason why the die appears twice, right, is that the top one is for if my coin landed on heads, and the bottom one is for if the coin landed on tails. So it's still only one roll, but it's accounting for the two possibilities of my coin flip. That's why it seems to appear twice. Okay, so if I go from the start of the tree diagram and I draw this path going along to the H and then down to the 5, that would mean I flipped a heads and rolled a 5. If I drew a path from the start again, going down to the T and across to 3, that would mean I flipped tails and rolled a 3. Okay. Now, those are the two ways. It's either using a table or using a tree diagram. And you might be asked some questions about, filling in one or both of these things. But when we go to calculate probabilities, you don't really have to use them. I don't actually like to. I don't really see a need for them. The important thing is this. In both of those cases, we saw that the total number of outcomes was not 2 plus 6, it was actually 2 times 6. There were always 12 outcomes in total, right? And that's true in general, that whenever we do multi-step experiments, we do one thing after another, right? The total number of possibilities can be found by multiplying the number of possibilities at each step. And this translates directly to probabilities as well, right? That the probability of two things or more happening one after the other can be found by multiplying the probabilities at each step. So say we took the example we saw just then. We flip a coin and we roll a die. What's the probability of flipping a tails and rolling a 3? Right. Now notice I use the words and then. I'll come back to that in a second, right? It's flipping a tails and then rolling a 3. And what that means is we can multiply. We multiply the probability of flipping a tails by the probability of then rolling a 3. And as we know, hopefully from last time, that the chance of flipping a tails is 1/2. The chance of rolling a 3, that's only one outcome out of 6. And so we multiply those and we get 1 in 12. Okay. Notice I keep using the word and then, right? That I put a little time element to it. Okay, now it's important because now for the coin flip and die roll, well, there's no link between them. My result of flipping a heads or a tails doesn't affect what happens with the die. But in other multi-step experiments, maybe the outcome of the first thing will have some effect on the second thing. So let's take a look at this. We're drawing 2 cards from a deck, and what's the probability of getting 2 aces? Like maybe when you're playing certain games and where you have 2 cards, I won't say which game, but you know, what's the chance of getting 2 aces in a row, right? So let's bring back the cards. You got to see that getting 2 aces is not a single event, is not something you can directly do, because getting 2 aces actually involves 2 steps. You have to draw an ace and then draw another ace. So what we just learnt was that the probability of that happening is where you draw an ace and then you multiply that by drawing another ace. Okay? Now, again, why do we keep using the word and then? Because getting your first ace will affect the chance of getting another one. Right, because you've taken one out, it's going to actually affect the numbers there. We'll see exactly how now. Okay, so let's say we look at the chance of just drawing that first ace. Let's just worry about the first thing. Okay, drawing an ace first. As we saw last time, we have 52 cards. We have 4 aces. Hopefully I can do this part faster now. And so the chance of drawing 1 ace is going to be 4 possibilities out of the 52 in total. And then we need to draw another ace. So what then? Well, we've already got one, right? And that means that we should remove one of the aces. I don't care which one, but one of them from the pile. So rather than having 52 cards in the pile, I've already got one. I've got an ace, right? So there's now only 51 cards in the pile. And rather than there being 4 aces, there's only 3 because I've got one already. And so the chance of drawing another ace, well, there's only 3 possibilities left to choose from out of 51 cards. And so that's going to be our probability there, right? Times 3 out of 51. Okay. And so when we put that all together, the answer we're going to get then is 1 out of 221, and I would calculate that every single time. Okay. All right, so that's multi-step events. That's all for today. Thanks for watching. See you next time.